Same thing as q squared. Q squared is 0.36. Are you good with that, Tristan?
Yeah, I understand it.
So that part we're good with. Cool. Take the reciprocal. So really, and what am I skipping here? What I did before, really it is this that we're skipping. Right? We never write this, but this is what's going on in your brain mathematically. This is going to take that out. So Q equals the square root of 0.36. So that Q equals 0.6. Cool. And then just like I said before, I know P plus Q equals 1. And so I know P equals 1 minus Q. And I know that Q is 0.6, so P equals 1 minus 0.6, P equals 0.4. This stuff I usually never write down. If you get into not so common numbers and things that are so easy to work with in your mind, you'll want to write it all out. Or if you want to make sure, hey, if I make a mistake, I want to be able to go back and figure out where that mistake was. Because if you don't write stuff down, it's impossible to figure out. And then you got to start over, right? So it's going to take a little longer to be meticulous, right? But if you make a mistake, you're going to be happy you were meticulous. So it's totally up to you. I know P equals 0.4 because you could just be like, well, if Q is 0.6, well, to get to 1, it's 0.4, done, right? So if I have P, now what can I do? Put Q is 0.6, P is 0.4. What can I solve now? We can do, you can do either P squared or 2PQ. I usually do P squared first just to, so P squared equals 0.4 squared. So P squared equals what? 0.16. So 16% of the population is what? What kind of dominant? Homozygous dominant, right? Cool. And then 2PQ, we have 2 times P, which is 0.4 times 0.6, right? Because that's Q. So what do we get? 0.48. So 0.48 or 48% of the population are heterozygotes. And if we want to check, we know P squared plus 2PQ plus Q squared equals 1. P squared is 0.16, Q squared is 0.36, and 2PQ is 0.48. 8 and 6 is 14, and 6 is 20, 2, 3, 6, 10, 1.0. So you can check your work that way. So whether you were here yesterday or not, does it make sense how to go through and attack Hardy-Weinberg?
Yes.
Okay. So, this question here, like I said, regardless of the questions that you get, I always solve for all the variables in Hardy-Weinberg. Because I never want it to be that, 4 questions later it was like, in question 2, the population and I gotta go and work that problem again because I didn't get all the information. Just go ahead and take the extra minute and a half, and get all the variables solved for it. Then you can answer anything that may be asked. Yes, no? So for here, sample of the population found 36% are homozygous recessive. What is the frequency of the dominant and recessive alleles? What is the frequency of the dominant allele? What do we look for? P. and P is 0.4, right? What is the frequency of the recessive allele? That's Q, 0.6. Right on? Is there anybody that's a little foggy on this? Yes? No? After this, when I added all this up. So I referred back to this equation. P squared plus 2p cubed plus q squared equals 1. So p plus q equals 1. So 0.4 plus 0.6 equals 1.
Oh, so we did that one and then that one after, or it doesn't matter?
It depends on what information we're given. If we're given information about individuals, then we start with this one. If we're given information about alleles, then we start with that one.
Oh,
Okay? Oh, did you get all registered? You're good? Alright, so P plus Q equals 1, P squared plus 2PQ plus Q squared equals 1. We're given Q squared equals 0.36. Remember, solve for P and Q first, regardless. As a general rule, but, right? So here's our word, Q, the square root of Q squared equals 0.6. P plus Q equals 1, P plus 0.6 equals 1, P equals 1 minus 0.6, P equals 0.4. Alright, everything we did up here on the board. Answer, the frequency, so they didn't break everything down, the frequency of the A allele is 40%, or the dominant allele is 40%, frequency of the recessive allele is 60%. Are we all good here with the first practice problem? Yes, ma'am. Oh, that's good. Alright, so, what do you think? 3 minutes to solve a problem?
yeah.
5?
Like 10.
Alright, we'll split the difference and we'll do
8.
3.
What?
Go.
So that's Q squared.
Split the difference. It's not splitting the difference at all. Doing what I want to do. Go ahead.
In the word column, how do you differentiate if it's giving you
Oh my God, no.
the in the what?
Okay, so, so we're telling you, alright, this is our trait, we're looking at the double. Albinism is recessive, so 10% of the mice are
Oh,
recessive.
then,
So that's looking at 10% of the population is recessive. So we're looking at population first. So population is, okay, and population, yeah, good, Q squared, and then roll from there. Yep. So remember when I went here, Q squared is 136. No, that's squaring it, left take the square root.
This is square root of 0.1.
Square root of everything.
It's just like 1.
No.
Well, it's 0.36.
Do you have rules for rounding it up?
Basic rules, so that would be point.
3, 2. So that P equals 4.
No.
Q. And then P equals.
1 minute and 10 seconds.
What?
Come on. 1 minute and 10 seconds, go.
So then this would equal 0.7.
Ladies and gentlemen, your AP exam is going to be timed, right? You've got to be proficient at thinking and working under pressure.
0.6.
Anybody who doesn't get this done, their letter grade drops by 1 full letter. Progress reports come out tomorrow. Okay.
Then I can't go on.
It's not right.
Am I gonna get an E?
It's white horse. Are you gonna get an E? In your case, Carly, probably two.
Today. The project I have for that, I haven't.
19 seconds.
Come out tomorrow.
That's why it's like this. It's like this, like
Make
that.
sure-
3.2.
Does anyone wanna volunteer to do it on the board?
Do we get extra credit?
Nobody will get a raffle ticket.
Ooh, that's good for a chance at a candy bar.
Is it a candy bar?
What did you get wrong?
Mr. Whale cutting, I can't.
Did you say, what if you get it wrong?
Yeah.
Ask the
Then you gotta
class.
give me a candy bar.
Okay, I got it.
You shouldn't
Well,
be
wait.
afraid to be
Alright,
wrong.
here's what we should do, is when I was taking my, physics courses, we had our room of 40 kids, and my professor had a random name generator, and he would give us a problem to work out, and then pull the random name generator, and everybody got the same score. Whatever that kid went up and did on the board was everybody's credit. Yeah.
Help people.
Oh. You would help, you could ask for a little help, you still had to do it on your own, right? They couldn't do it for you. But yeah, so everybody knew how they performed would affect everybody else, everybody studied.
So are we doing it, or?
We should, right? Yeah, let's do that.
Oh. No, you can help though, I'll give you a ticket. If you solve the problem on the board,
I got it.
I'll give you a
I did
ticket
it
for
like
the
10
raffle.
minutes ago.
Alright, let's go, who's up?
Or do you want me to, wait,
Who wants to go? Somebody go, who's confident? Let's go.
okay, Ellie.
Let's go, Ellie!
Guys, we don't have to get 8.
And if you could explain your thinking, because that helps us, especially if you write things out different than we would.
You can pull the board down.
She's gonna get like.
Yeah, pull that down, dude, so you can. And write bigger.
Put that back to.
So first step, write down the equations, right? P plus Q equals 1, P squared plus 2PQ plus Q squared equals 1. Writing down the variables we want to solve for, P, Q, P squared, Q squared, and 2PQ. Writing down anything we already know. 0.10 is Q squared. Why do you know that's Q squared? Ellie? How do you know that's Q squared?
10% of the population of mice albino, and it's recessive.
So yeah, it's telling us albinism is recessive and 10% are recessive. Q squared is homozygous recessive. The only way you show a recessive trait is if you're homozygous recessive. Q squared has to be 0.1. And how did you get Q?
The square root of 0.10 is
So square root of 0.1 is 0.32. It's like 0.316, right? But we're gonna round up to 0.32. So if Q is 0.32, then she's written down 1 minus 0.32 equals 0.68. Why? Because 1 minus Q equals P. She just solved for P, 0.68. Now she's going with P squared, so 0.68 squared Is that 6.8 or 6.5? So 0.46 is p squared, and now she can solve for 2p cubed. 2 times p, which is 0.68, times q, which is 0.32, and it gives us 0.40. So, what is the answer to the question?
0.40.
What is the frequency of homozygous dominant and heterozygous individuals in the population?
0.40.
Homozygous dominant is going to be equal to the 0.68, or I'm sorry, the p squared. Okay, so all your math is right. Is there, and thank you, ma'am, for giving it a shot. All our math is right.
You were right, yeah, nothing, you were crazy enough to do
I can hear it. Do we agree with her answer? How many agree? How many disagree? How many don't know? Why don't we know? Alright. We should have raised our hand for disagree.
Oh, yeah, 40, it's
Wait. And you did all of the math correct. This is asking for homozygous dominant. Which variable is homozygous dominant? P squared, right? So this should be. So this is going to be the most common mistake you make during this. Is going to be answering for the wrong question, right? Even though you got all the math right and everything. So if we look at this, we've got all la 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 la. So 46 homozygous dominant individuals is 46%. Frequency of heterozygous individuals is 44%. That's 0.96. That should be correct. Something's wrong. Wait a minute. Let's work some math. So, 0.1. You write down the wrong one. 0.435. So we round that to 0.44. Right up. What are you guys doing?
Got 1 minute.
All right,
I can't get it
ladies
out.
and gentlemen.
A couple of things. One of them is how you make up points on your exam, including the FR field.
So, ladies and gentlemen, let me see your little packet where we're at. So, practice, and if you struggle with any of that, ask Ms. Laney to review that with you tomorrow, please. And then we'll continue with the lecture.